Hi all, welcome to the video on dealing with matrices using numerical Python module called as Numpy. Numpy provides high performance multidimensional array objects and various tools to work on those objects. Matrix is nothing but the arrangement of numbers as rows and columns. As an example, I am considering a matrix here with 3 rows and 3 columns. So row 0 is having the elements 10, 20, 30 and row 3 is having the elements 70, 80, 90. In the same way, you can consider the column 1 with elements 10, 40, 70 and the column 2 with elements 20, 50, 80 and column 3 with 30, 60, 90. Here, individual element of a matrix can be accessed by using its row number and the column number. First, we need to import the Numpy library by using import statement. Here I am giving the alias np for that Numpy. Since I am using Jupyter Notebook, to execute the content in any cell, we need to press Shift and Enter. Now the Numpy module is imported successfully with an alias np. Now this particular statement creates an object m1 of class array. Here I am using array class in Numpy module with lists of list as input. Here each inner list gives a row of our matrix. Now I am going to access the individual rows. So the first row can be accessed by using the index 0. Then I am going to print that first row. Then we got the first row 10, 20, 30. In the same way, we can access the remaining rows with the index 1 and 2. Now m1 of 1 gives us the second row and m1 of 2 gives us the third row. If I run this, then we got the individual rows separately. We can also get the particular row by using this particular notation also, where 2 represents the row number and the column represents all columns. If I run this cell again, at the end I got the third row as it is. Now we are going to look at how we can get individual columns. We can access the first column by using the index 0 and where the column represents all the rows. And in the same way, the second column can be accessed by using index 1 and the 2 is the index for the third column. If I execute this, 10, 40, 70 is the first column, 20, 50, 80 is the second column and we got the third column 30, 60 and 90. Now we will see how you can access individual elements. Individual elements can be accessed by using its row index as well as column index. Here now I am showing how you can extract the diagonal elements. So 0, 0 here represents element of m1 matrix at row index 0 and the column index 0. Here in the next print statement I am going to access an element present at second row and the second column. And finally I am going to access the third row and the third column element. If I execute this, then I got 10, 50, 90. Those are the main diagonal elements we got. Next type of matrix is identity matrix. So identity matrix is basically a square matrix, which means the number of rows is equal to number of columns. Here I have considered 3 by 3 square matrix, where you can find ones on the main diagonal and zeros in the remaining positions. Main diagonal elements are elements at position row index is equal to column index. In Numpy we have a function identity to generate identity matrix of size n. Here I have given 4 as a size, then this particular statement generates an identity matrix of size 4 by 4 into i4. Then if I print i4, then I will get identity matrix of 4 by 4 size. If you observe here, the default data type for array is float. We can change the default data type by specifying a keyword argument d type. Now I am going to generate identity matrix of size 3 by 3 where the element data type will be integer. If I run this, then I got an identity matrix of size 3 by 3 where the elements are of integer type. Going forward, the next type of matrix I am going to generate is zero matrix. We can also call this as null matrix. So which is a matrix of size m by n. No need to be a square matrix, it may be any rectangular matrix where the number of rows may not be equal to the number of columns. But here the thing is, all the elements in this particular matrix will be zeros. In Numpy we have a function zeros to generate a matrix of zeros of size n by m. Here I have given 2 rows and 3 columns as dimension. In Numpy always dimension should be specified as a tuple. If I run this, then I got a 2 by 3 matrix of zeros. The next one in the list is ones matrix, which is a matrix of size m by n, where all the elements are ones. We have a function ones to generate a ones matrix of size n by m. Here I have specified the dimension as 2 by 3. Then automatically this ones function will generate a matrix of size 2 rows and 3 columns with all ones as elements. Here we got a 2 by 3 matrix of ones. Now I want to generate a 3 by 2 matrix of all tens. For that I am using the ones function to generate a 3 by 2 matrix of ones, and then I am multiplying that 3 by 2 matrix of ones with a scalar 10. Then automatically I will get a 3 by 2 matrix with all tens. So next method with Numpy array is diag, which is used to extract the main diagonal of the matrix. Here I am considering a matrix of size 3 by 3. So where the main diagonal elements are 10, 50 and 90. If I run this cell, so we got Numpy array with elements 10, 50 and 90. So the next one is matrix transpose. So matrix transpose is obtained by flipping a matrix by interchanging its rows and columns. Here if we consider the input matrix A, so where the first row is 10, 20, 30, which will become the first column in its transpose, and the second row 40, 50, 60 becomes the second column of the transposed version of A. Numpy is having the transpose method to get the transpose of the given matrix. Here I have considered a 2 by 3 matrix, and then I have used the transpose method to find out the transpose of that matrix, and then I have loaded that matrix into AT. Then if I display that AT matrix, which is the transpose of the given matrix. So next, addition and subtraction of the matrices. We can add or subtract two matrices if they have the same dimension. That is, both the matrices must have the same number of rows and the same number of columns. Then only we can perform either addition or subtraction. Addition or subtraction can be done on the corresponding numbers with the same positions. Here I am considering M1 and M2 as matrices, and then I have used plus to add these two matrices and to produce that sum matrix into M3, and then I am displaying that M3. Then I got the sum of these two matrices as M3. Now I am using the subtraction of M1 and M2 by using minus sign. So that difference matrix will be loaded into M4 matrix, and then I am displaying that M4. If I run this cell again, I got the difference matrix. So next one is element by element matrix multiplication, where the requirement again is both the matrices must have the same dimension. Here I am considering A and B as two matrices of same dimension, 2 rows and 3 columns. Then if we perform element by element multiplication of these two matrices, we will get a matrix C, where the 10 is multiplied with 100 to get 1000 in the matrix C. In the same way, 60 is multiplied with the corresponding element in the B matrix 600, and which produces 36,000. In Numpy, asterisk is used as an operator to perform element by element multiplication. Here I am considering M1 and M2 as matrices of dimension 2 by 3. If I multiply both element by element, I will get the result into M3 matrix, which is this one. So next one is the matrix multiplication. For the matrix multiplication, the requirement is the number of columns in the first matrix must be equal to the number of rows in the second matrix. As an example, if I consider two matrices A and B, A is of dimension m by n and B is of the dimension n by p, where n is the number of columns in the first matrix A and B is having the same n number of rows for the multiplication. If we multiply both the matrices, then we will get a product matrix C, which is having the dimension m by p. As an example, I am considering A and B here. Here A is having the size 3 by 2 and B is having the size 2 by 3. So in the product matrix C, the first element is nothing but the sum of products of the first row of the A matrix and the first column of the B matrix. So that is 9. And the second element in the product matrix is nothing but sum of products of the first row of the first matrix and the second column of the second matrix. And the third element in the product matrix is nothing but the sum of products of the first row and the third column. In the same way, the first element in the second row of the product matrix can be obtained by performing the sum of products of the second row of the first matrix and the first column of the second matrix. And the second element of the second row of the product matrix can be obtained by finding the sum of products of the second row of the first matrix and second column of the second matrix, and so on. Here I am considering two matrices M1 and M2 as I mentioned in the example. Now I am performing a matrix multiplication by using a method available in Numpy dot, and then the product matrix now is M3. If I run this cell, then I got the product matrix, this one. We can also achieve the matrix multiplication by using @ operator. Here I am considering the same matrices M1 and M2, and then now I am using M4 as a variable to hold that product matrix. If I run this cell again, then I got the same product matrix in this case also. Next one is to find out the determinant of the matrix. So determinant is a single value calculated from a square matrix. Determinant is mainly used to find the solution for the system of linear equations. As an example, first I am considering M1 as a 2 by 2 matrix, where the elements are A, B, the first row elements, and C, D are the second row elements. Then the determinant of that matrix M1 can be calculated as AD minus BC. Now let us consider M1 is having the 4 elements 1, 2, 3, 4. Then the determinant of the matrix M1 can be computed as 1 into 4 minus 2 into 3. Then we got 4 minus 6, which is nothing but minus 2. We can compute the determinant of this 3 by 3 matrix as A multiplied with determinant of the submatrix, which we can get by ignoring the rows and columns containing A. And this is the row we need to ignore, and this is the column we need to ignore because both are having the A. Then the remaining elements are E, F, H, I. That gives a 2 by 2 matrix. For that we need to compute the determinant. Minus B multiplied with determinant of D, F, G, I. So this is the submatrix we got. We can get the submatrix by ignoring the row containing B as well as column containing B. Plus C multiplied with determinant of another submatrix, which you can get by ignoring the row and column containing C. And finally, this is the equation we got to find out the determinant of this 3 by 3 matrix. Then if we consider this as an example, then we got 46 as the determinant of that 3 by 3 matrix. Now I am considering the 2 by 2 matrix M1. Now I am going to find out the determinant of the 2 by 2 matrix by using det method available in a submodule linalog. So linalog is a submodule available in Numpy which is having all the methods related to linear algebra. Then if I display the determinant of the 2 by 2 matrix, then I will get minus 2. Now I am going to find out the determinant of 3 by 3 matrix. Our 3 by 3 matrix is there in M2, and then I am using det method available in linear algebra submodule of Numpy. If I display the determinant of the 3 by 3 matrix available in D2, then I got 46. So next one is the inverse of a matrix. So A inverse can be computed with the help of determinant of that matrix. To compute the inverse of a matrix, that should be a square matrix. If you multiply a matrix with its inverse, automatically we can get identity matrix I. Now let me consider a 2 by 2 matrix which is having the elements A, B, C, D. Then we can find its inverse as 1 by determinant of that A matrix D, A minus B minus C. Then I am considering A as 1, 2, 3, 4 as an example. Then A inverse can be computed as 1 by the determinant of that A, which will be 1 into 4 minus 2 into 3. Then we can get 4 minus 6 in the denominator. And the matrix now will be 4 minus 2 minus 3 and 1. Then finally we will get minus 2, 1, 1.5 minus 0.5 as the inverse of that matrix. So in order to compute the inverse of a square matrix, we have a method INV in the linear algebra submodule of the Numpy. Then my input matrix A is equal to 1, 2, 3, 4. Then if I run this cell, we can find the inverse, that is minus 2, 1, 1.5, minus 0.5. Now I am computing the matrix multiplication of A and its inverse, and then I am converting the type of the values as float 16, and then I am displaying the I. Then I will get the identity matrix. The next thing we are considering is solving the system of linear equations by using matrices. A system of linear equations is just a set of two or more linear equations. Here I am considering two linear equations described by a linear system, where x and y are the variables. The first linear equation is having the x coefficient 2 and y coefficient 4, and which is having a constant value minus 8. And the second linear equation is having x coefficient 1 and y coefficient minus 8 and a constant 6. To solve this system of linear equations, I am extracting three different matrices out of these linear equations. The first matrix is a square matrix of all the coefficients, and the second matrix is x, which is nothing but the variables x and y of the linear equations, and the third matrix is b, which is having the constants minus 8 and 6. Then we can establish the relationship between all these three matrices to get the same linear equations. We have an equation like matrix A is multiplied with matrix X to get matrix B. As a next step, I am multiplying both these sides with A inverse. We know that if a matrix is multiplied with its inverse, we can get identity matrix. Then A inverse multiplied with A gives us identity matrix. And if you multiply any matrix with identity matrix, we will get the same matrix. Then I multiplied by X will get X only. And finally we got the matrix X, which is having our variables X and Y, is equal to A inverse multiplied by B. Now here I am considering the matrix A as 2, 4, 1, minus 8, and the matrix B is minus 8 and 6, and which is a column matrix. And then I am finding the matrix multiplication of inverse of A and B. Finally we got X. If I display that X content, then we got minus 2 as the value of X variable and minus 1 as the value of Y variable. Now here I am using another print statement to extract X and Y values separately with the help of indexing. Then if I run this cell again, then I got the X value minus 2 and Y value minus 1. Now we are going to verify the same solution with the help of graphs. Now I am using the graphical method for finding the solution of system of linear equations. For that I am using Desmos web application. Then our first linear equation is 2x plus 4y is equal to minus 8. Then we got that curve in the green color. And our expression number 2 is x minus 8y is equal to 6. Then we got that curve in the blue color. Then if we observe the point of intersect, we got minus 2 and minus 1. That means the solution for the system of linear equation is at x variable value is minus 2 and y variable value is minus 1. We got the same result as in the case of Numpy. Guys, that's it. That is the end of matrices by using Numpy and the verification of solution for the linear equations with the help of graphical method using Desmos app. Thanks for watching guys. I will meet you with a new topic in the next video.